Okay, this is going to be a lesson on SLT 12 in Unit 2, Topic 2. We're going to interpret key features of polynomial functions given different representations. So we're going to start on page 11. Everyone go ahead and turn to page 11, pause the video, and describe as many key features as you can for the two graphs on page 11. Okay, so I'm going to start. If you haven't finished, go ahead and pause the video again. And I'm going to do the end behavior. So on the left side, as x goes to negative infinity, I see the function goes to negative infinity. On the right side, as x goes to infinity, I see the function goes to infinity. Because the end behavior are opposite, I know that that is an odd degree. I see I've got x-intercepts at 0 and 6. Notice I'm not putting those in parentheses because I don't want them to look like an ordered pair. I have a y-intercept at 0. Now, increasing and decreasing intervals. So what I'm going to do here is I'm going to kind of trace my graph from left to right. And I'm going to notice that here I have an increasing interval. And then right here when x is 0, the graph starts to decrease. And then, green. When x here is 4, the graph starts to increase again. See how I draw these vertical lines? Because I cut the graph with vertical lines to describe my increasing and decreasing intervals, I'm going to say that this graph is increasing when x is less than 0 and when x is greater than 4. Because here's 0 and everything less than, and then 4 and everything greater than. It's decreasing between 0 and 4. So I'm going to say 0 is less than x is less than 4. I have a relative minimum. Now, because it says occurs at, I want to write down the ordered pair. I have a relative minimum that occurs at the point 4, negative 32. And we call that relative because it's not the lowest point in the whole function, just in that area. Clearly, this function goes down further than that. And same thing for 0, 0 as my relative maximum. Now, number 2, I got a lot going on. First off, my end behavior. On the left side, the function is going up, and on the right side, the function is going down, and that tells me I have an odd degree. I've got x-intercepts at negative 2.64, 1, and 2.52. I have a y-intercept at negative 4. So let's cut this up. I have a decreasing interval to start on the left. I always read my graph from left to right. It decreases, decreases, decreases. And I'm going to draw my nice vertical line here at negative 2. And then it starts increasing. And it's kind of roller coastery, but it's important to note that this point at 0, it doesn't stop increasing. It just kind of, that's called an inflection point. And we'll learn about those later in our math career. So it's increasing, increasing, increasing until we hit this maximum right here when x is 2. And then after that, we have a decreasing interval. So we are decreasing when x is less than negative 2 and x is greater than 2. And between negative 2 and 2, the graph is increasing. We have a relative maximum at 2, 12, and a relative minimum at negative 2, negative 20. Now I just want to point something out. I'm putting an ordered pair down because it says occurs at. If I was just looking for a relative maximum is, I would say relative maximum, did I put these backwards? I did, I'm an idiot. Sorry. There's the minimum, this is the maximum. If I was looking for what the relative maximum is, the relative maximum is the function value. So the relative maximum is 12, just the y value. So like for increasing and decreasing intervals, we always use an x value. For a maximum and a minimum, we normally use a y value. The only reason I'm writing these as ordered pairs is because of the word at. Okay, hey, look at that. So here are the answers to last night's homework. If you need to pause the video, check them, go for it. And go ahead and turn to page 12. What I'd like you to do is please pause the video and type number 3 into your calculator. negative x to the fourth plus 4x squared. Oh, poop, I hate these kind. Fourth plus 4. Okay, so hit graph. That's pretty, looks like an M. So the first thing I'm gonna do is I'm just gonna take my calculator and I'm really going to get a good sketch of what's going on here. And notice when I make my sketch, I'm not putting down any scales. I think it hit 0, I'm pretty sure. And I want to get some key features here. So the first thing I'm going to do, if I want to get this maximum point here, is I'm going to press second, trace, and I'm going to pick maximum. And you'll see I have this little cursor, and it says left bound. I'm going to move my cursor until it's on the left side of the maximum I'm looking to find. I'm looking to find this maximum. So I move it to the left side, and I press enter. Then I move the arrows to the right side of the maximum and press enter. And you see that the maximum point I'm looking for is between those two arrows. And once I've done that, I'm going to press enter when it says guess. And the maximum is at, I'm going to write down the whole ordered pair because I'm going to need it for a couple different things. So I'm going to go 3 decimal places because that's AP standard. I'm 99.9% sure that this is the 0.00, but I want to make sure. So I'm going to go to second trace, minimum. I'm going to put my cursor on the left side of the minimum, press enter. The right side of the minimum, press enter, and you can see that that minimum is between the arrows. And I'm going to press enter for guess. Ooh, now I like it, it did this. These values I see here, they're a little scary, but whenever I see this e negative 7, this is really like 6 times 10 to the negative 7, which is just scientific notation for something pretty close to 0. The calculator's not that smart. It's 0. Now I want to find that last point, and I'm pretty sure that it's probably 1.414 because it looks pretty symmetrical, but I want to make sure. So again, I'm going to go to the left side of the maximum, the right side of the maximum. Yep. All right, I'm also now, while I'm in calculator mode, because I need my intercepts, I know I've got an x and a y intercept at 0, 0, but I don't know what these x intercepts are. So the way I'm going to find that with my calculator is press second, trace, and now I'm going to pick number 2, which is 0. Just as an aside, I really think that number 0 should be 0, because I just think that would make more sense, but I'm not in charge here, so it's number 2. I have 2 x-intercepts I'm looking for. I'm going to find this one first. I'm going to arrow. So now you see, right now, see I'm slightly above it. I'm really on the right side, because here's the x-intercept, I'm on the right. I want to arrow, I'm still on the right, and when I jump under the x-axis, I'm on the left. So now I'm going to jump just a little bit, and you can see like these arrows are really close, but my x-intercept is between them. Oop, -2. I bet the other one's +2. Just as an aside, if you get the error no sign change, that means your arrows were too close together. So this one's on, now I'm on the left, and now I'm on the right, and yep, 2, 0. So now I'm ready to answer all of these questions. So the end behavior here, as x goes to -infinity, well, both of them go down. It's an even degree. The x-intercepts are -2, 0, and 2. The y-intercept is just 0. So I'm going to start my increasing, decreasing intervals because I have a lot going on here. So here's the first interval. Then I'm decreasing here. Then I'm increasing here. That purple. And then over here, oh, the purple has no tip. Fail. There's one. Okay, so this first increasing interval is increasing when x is less than -1.414. Now, it's also increasing between, remember we're using x values, between 0 and 1.414. Now I have these 2 decreasing intervals. This first decreasing interval is between -1.414 and 0. And then everything after 1.414 is also decreasing. Put a line here to separate them. Cool. Awesome. So now I've got a relative minimum of 0, and it occurs at 0, so 0, 0. A relative maximum occurs at, and I have 2 of them. I could really just say 4 because the maximum is 4. So 4, 4. Remember, it's a relative maximum of 4 that occurs at these points. If I just asked you for the maximum, it would just be 4. All right, so go ahead, pause the video, type number 4 into your calculator, and see if you can get all of these points like I did for the number 3 on your own. Okay, at this point, if you have not tried this on your own, you stink. Pause the video, try it on your own. Don't be a cheater. Just copy my answers. That's not cool, man. Ooh, pretty. I think this goes through 0, 0, but I'm not sure. I'm actually, right now, I'm gonna go check at my y-intercept. Another way to check your y-intercept is you can go look at your table. Oh, there it is. Wherever x is 0, that's your y-intercept. So that's a good thing. You should probably write that down. To find the y-intercept, just look where x is 0. This is so not gonna be the scale. Whatever. I gotta find this guy, and this guy, and this guy, and this guy. I think I'll start first with my maximums. So second trace, and I picked maximum. Now I'm going to the left side of the maximum and the right side of the maximum, and I press enter for guess, and I get -1, 1.25. Now I'm gonna do the same thing to find this minimum. I'm gonna go second trace. Well, that's actually better. Let's switch spots. I don't know if I can write there. The lighting is better. So minimum is number 3. Left side of the minimum. Right side of the minimum. Guess. So again, this is a calculator error. You need to know to round this to 3. So it's 3 and then -6.75. Now I need those 2 x-intercepts. So I'm going to go second trace. Oops, second trace, number 2. And since I'm close to this one, I'll find it first. Left, right. I don't really need to, I mean, in theory, you could move the cursor closer, but you don't have to. And I have 4.864. 54. And second trace. Left. There we go, left, right. And I've got -1.854. All right, now that I've like utilized my calculator, I'm totally done with you, goodbye. And I can answer all my questions. So here we go. On the left, as x goes to -infinity, the function goes down. On the right, as x goes to infinity, the function goes up. It's an even degree, oh, wow, I'm an idiot. It's an odd degree function. So intercepts, I have a y-intercept of 0. I have 3 x-intercepts, -1.854, 0, 4.854. All right, let me get my pencils out here. So I'm increasing until -1. Big old for increasing. And then I am decreasing. And now I am increasing. So my first increasing interval is when x is less than -1. And then I have another increasing interval over here when x is greater than 3. And then my decreasing interval occurs between -1, and 3. Remember, we're using x values because we read a graph from left to right. Also, when I'm talking about x equals -1, the graph only has one value there because it's a function. But if I was talking about y is -1, you can see I've got 1, 2, 3 y values at -1. I wouldn't know which y value I was talking about. But when I say x is -1, I'm definitely talking about this point. There is no confusion there. So I've got a relative minimum that occurs at 3, -675, and the relative minimum, remember, is -675. My relative maximum occurs at -1, 1.25, and my relative maximum is 1.25. All right, so ladies and gentlemen, your homework tonight is 13 to 15. If you need another look on how to do calculator stuff, there's a nice link, and hit it. Again, I'll slide through the answers, so if you want to just pause this video and check as you go, that's fine.